This is the Supermileage Windshield project. We started off by going to the Supermileage Club and asking them about their problems. They had issues molding the windshield out of polycarbonate. Using this fiberglass mold, we were able to measure and model in Creo, which allowed us to CNC the mold. And after we CNC'd the mold, we used our materials, which were PET, PMMA, polycarbonate, and PETG to form windshields. Next, we took our Creo model and we put it into finite element analysis. We found that on our mechanical test, we'd see dimpling, but no critical failures. We also put in a transient thermal analysis for polycarbonate. This validated our hand calculations for our heat transfer equations.
Next, we ran DMA and DSC to get a temperature range for our material in the oven. For our DMA, that was our low end at the time, hand delta peak. We tried to focus on that. And then for our DSC, we tried to find the on-site melting temperature to get the high range and the processing temperatures for the amorphous materials. Next, we ran an OFAT on the polycarbonate 3.2 millimeters. We noticed that our oven temperature was set in compensation temperature on the MAC thermoformer because that is what was on control. Oven time was also different than our hand calculated times, and we had to watch for excessive sag. Notice our bubbles forming at the higher temperature at higher times, and at our lower time and temperature, we noticed that it had difficulty forming. Pictured are some of the results that we got after thermoforming our materials.
We had 4 specifications for this project: light transmittance, optical distortion, impact force, and weight. The first was light transmittance, where all of our materials passed. Our next specification was light distortion, where again PETG and 1.6 millimeter polycarbonate performed the best. For mechanical specifications, we wanted our windshield to withstand 10.4 newtons of force. All of our windshields passed the specification. After weighing the windshield, we discovered that 1.6 millimeter polycarbonate and PETG were the only 2 that passed the weight specification. In conclusion, we suggest PETG and 1.6 millimeter polycarbonate as the optimum windshield material.